Oh, um, we should be good here. So let's get, this is my bad. This should be here, and this should be here, and this should be there. And oh, there we go. That's what we want. That's what we want. All right, we're on. So I'm excited. I got really into doing this the other day, and I want to keep going with it. We'll do RP later, obviously. I'll do that later in the night. But after work, when I have my opportunities to, I will be streaming. And oftentimes it'll be my studying. So let's talk about where we left off, actually. I'll bring in my browser. It's this one, and I will switch browsers, and I will make sure that it's connected. I wish it was automatically connected. I don't know how, so okay. So we walked through what a linked list is, and today we're gonna traverse linked lists. The whole idea here is like, man, I'm not super great with these algorithms, especially when it comes to Java. I never took a class on it. So I'm going through step by step so I can perfect what is passive knowledge at this point. I haven't needed some of these algorithms. Don't get me wrong, I know a bunch of algorithms, and like, I could probably, obviously I know enough to be dangerous because I'm a professional in this field, but I want to get better, right? I've never had to like pass a Microsoft coding exam or something like that because I haven't needed to because I'm focusing on ML. All right, so we're gonna talk about traversing linked lists, and I really enjoyed doing that yesterday, and we're gonna do it through Java because I don't know Java at the top of my head, and yeah, that's gonna be the thing. So let's get started. I'm gonna walk us through what we did last time. This is a highly annotated node, and we're gonna keep going. We're gonna keep going with it. All right. So you've got this node class, right? It just says review. The node starts with it initializes with some objects. These objects are the next object, which is equal to null, and is called the node class, right? So it's the type of the node class. And then you've got this data object, and this data object is going to be an int. All right, so every node is going to be an int in the linked list, which you can think of as an array, right? Because the whole point of that we're doing for this is that an array is, if it's dynamic, then, right, we can keep adding to it. It's not static memory, so it's very handy to have. If you have an array and you're like, I want to add to the array, that's what a linked list is. Okay, so you've got this constructor object, as I understand it, and this constructor object conveniently takes an int. Well, we have an int up here, so that's going to be interesting. And in fact, if you want to, you can assign, and you should, data as an int to the int that you're passing to node. So you're saying, okay, construct a node and give it an int, and that int is going to be data. So far, so good. All right. And then we did something else. We said, okay, well, what if I wanted to add to the nodes? That is, I want a list of nodes. How am I going to do that? How can I append a node to the tail? Well, you're not going to return anything. You're just going to add to the object itself, right? So we have void here. That makes sense to me. Next thing I'm going to do is, let's see, we get append to tail, and you're giving an int. Well, that makes sense because we're trying to create a new node. We're trying to append a node to the tail. So first things first, you say, well, I want this to be end, and end is going to be type node, and you're going to create a new node. You're going to construct a new node. It's not going to be the same node. You're going to construct a new node passing an int, which is a required thing because it needs an integer. And then you got this object, which if you know Python is sort of like a self-referential thing. It's saying, okay, well, this thing being the node class here that we had already created, we need to be able to refer to that within the space. We're gonna call that n. It could be anything. We're calling it n, and of course it's node type because it is itself, right? Fair enough. So let's see some examples. All right, so we create a node object. I did this note before, and the node is of type node. So we're creating a node object. It is of type foo, or sorry, it is called foo. It is type node. And we're saying, all right, well, the first node.next would then be null, right? Because the first one we create in a linked list, well, that's going to be next dot equals null because that's what we assign it to. Great. Now, what if we wanted to append to tail? All right, so first we say append to tail from this object. So we go straight to next equals n because we'll see that next is already null. So we can just say if it's null, then assign it to end. End is just a node. End could be called anything. We called it end, right? So that's what end is here, right? So we start again with this idea of this class node. We're just trying to traverse a linked list here. The idea being we want to just start to understand what these things are. And I was actually looking into it today because I was kind of curious about C#, which is what a server I play on is developed in. And C# is basically Java, it turns out. So like learning this stuff is not just useful for itself, but it turns out like many languages, and I don't just mean coding languages, but languages such as Java, when you know one, learning others or having them applicable to other things is much quicker. So I was just looking on there. I'm like, this is basically Java. Great. So now we're learning more than one thing. We can be more dangerous. And again, as we get more nuanced into this type of stuff, right? This is not just professionally interesting. It can be existentially and, conceptually interesting. So it may start as sort of like, why are we doing this? But to me, it's kind of interesting in and of itself. Also, I'm already doing this. I'm studying for this stuff on my own because I like to learn. And so that's why I'm doing it. Okay. So we have this node object. I've already gone over all this. If you're just coming in, then maybe go back to the earlier in the video so you can kind of catch up. But I've explained everything up to this point. So at this point, we're saying, all right, we want to append to tail. So we already appended to tail once. We had foo, and foo initially, since there was no list of nodes in a linked list, which is a dynamic array, as opposed to a static array, as opposed to a computer saying, you have a list of 3 integers. It is always going to be this size, so I'm calling it a static array. Well, that's not very helpful if you want to start adding to that list, right? So we have this dynamic array, which we called linked lists because it's just a conceptually easy thing to think of as a linked list. Okay, it's a link of nodes. Well, we start from nothing to 1, and we're calling it foo, and so the first element in our linked list is going to be 1. And the next object, since we assigned next up here, as null, and it's a node, we're saying the next node, because it's a node type, is null. Fair enough. And then what we did is we said append to tail, which is this method right here. And it's saying, all right, well, on the same object, we're going to create a new node out of an integer. In this case, it's going to be 2. And we're saying, create a new node and call it end. It's just what we're calling it. It could be any word we want, but we're calling it end because it makes sense to us. And make it make it a node. Excuse me. Well, fair enough. And also, since this is within this class right here, we can be self-referential. We can say, well, this is happening within the class itself. In Python, we call it self, right? Like that's what we would do in Python, but in Java, just so happens, and I'm learning this too. Again, this is part of why I'm doing this is because I don't know Java. They call it this. It's just semantic. All right, this is itself. So this node is itself, and we're going to call it n so that we can refer to it. So it is of node type, and it is n. Great. So we say the first node in the linked list is foo. It is going to be a value 1. Its next object is going to be null because that's how we start off any node object like we see up here. The second thing we see is that the next object dot next is going to be equal to n then because null is the first object, right? So if that's the case, if it equals null, then we just assign the next node to be the next in the list. But what happens on a third object? So now you go back to foo again. Well, foo starts from the top. And you say, I want to add 3 to my list, a dynamic list. How am I going to do that? I pass the integer into here. It's a new node, and you get this, but you're not done yet. You still actually have to do something with the code. Well, that's where this, this code happens right here. We're saying while, that is literally while a condition holds, in this case, this is a condition, it's between these two parentheses, while a condition holds, do a thing. Okay, what is the condition? The condition is while n, well, n is the self-referential, it's going to be foo in this case, it's going to be the node, while the node value next, which is just a word we're using, we're calling it next, but it does make sense because it is the next thing, that's why it's useful to call it next. While n.next does not equal null, that is, n.next has a value, in this case, n.next is 2, do a thing. Okay, so while n.next has a value, in other words, while n.next is not null, do a thing. And the thing we're doing is we're going to say change n.next to be n. Okay, what does that mean? Well, we know what n.next is. n.next, n is this, so it's just self-referential, which means it's this. n.next is a node because we see this node type here. Types are telling us what the thing is. It's actually really nice to have types. It might feel confusing because you've got this thing here, but it's actually really nice to have a type because it's telling you what the thing is going to be. In Python, you often don't do that, or you know, in the past you didn't do that. A lot of people are doing typing now because it's much better. Sorry for the glare. I don't, you know, it's like reflecting off my skin as if I'm, you know, Antarctica or something. But that's just what it is. So it's a node type. Okay, so it's going to be a node type, which means n.next is n. Okay, so you're saying get the next node type, which is a node, and just call it n. Now we're just going to use that node type. All right, we're going to keep doing that. And we're going to say, all right, are we done? Go to the next condition. Does this still hold? In this case, 2.next, because 2 is a node, is null. So this condition no longer holds. And since this condition no longer holds, we break out of the loop. We say, nope, we're not going to do it one more time. We're going to go down here. And since now we have end, we assigned it up here, we have this new node. We just haven't done anything with it yet. Then we can say, well, 2.next, which is null, is now no longer null. It is end. And since this was a node type, we can do that because this is a node type. End is a node type. We're allowed to do it. And that's it. That's literally how we append a tail. So that's what we covered last time. And I thought it was pretty fun. And I didn't know it going into it, like how to do this pretty well, but in Java, but makes sense to me. So we're going to solve some more problems today. The rest, what do we got here? We've got in every Java class function, if you want to run it, you got to do this public static void main thing, then string, then args. That's what's going on here. Okay. What else do we see? Well, we see, let's try creating an object. So I created the first object. We create a new node object, type node or type node class, and it's a new node constructor. Great. We call it foo. Then we're going to print out the value. Then we're going to append 2 to it. And then we're going to print the nodes. What is print nodes? Well, I created this little method here to iterate through the linked list, no matter what the length is. So if we run our debugger, which is a way to see step-by-step what's happening in the code, we can do that. Actually, we can, but I didn't run through it I didn't have breakpoints assigned. So a breakpoint will stop the code at the breakpoint. So let's just stop here and see what's happening step by step. So if I run the debugger, I'm going to stop here first at the breakpoint. And it's saying, okay, I've run this, I've run this, I've run this. Now I'm at print nodes. What's going on? Print nodes, first thing, while n.next equals null. Okay, well, n, in this case, is this, which means it's self-referential, which means it's the node class up here. It's node. So what's going on? We're saying n. We can even break into the object in a breakpoint, in a debugger. That is why it is very useful to use. Yes, so that is, I wonder if I can, I'll figure it out later. That is what's going on there. So we have a data and we have next node 2. So we have a next object here. Let's move forward in and we get this. Now we have system print at ln. The next number of the node is n.data. What do you think the first printout's going to be? I mean, we saw it up there, but it's going to be 1 because the first data object is 1. Now what we're doing is we're seeing n.next equals n. Okay, so now we're going to the next node because n.next is a node and it does exist because we put 2 in there. So now we're in this space. Go through again and we'll get n.node this time is 2, and then we print out. Why? Because this condition does not hold anymore. The next will be node, so we don't run this anymore. We just ran this and this. And there we go. Okay, so that's the full summary of where we left off last time. Now we're gonna actually have a problem that I don't know how to solve. I read it this morning and I was like, all right, we're gonna solve it later today. Here is the code and the problem. We're gonna work through the code and work through the problem. I don't know if I'm gonna solve the whole thing today. Depends on how my energy is. Some days I have more energy than others. So they give us this code, and we're gonna work through the code because I looked through it earlier and I was like, this is actually just like useful for me to know. But first things first, what are we actually trying to solve? So we're trying to solve a linked list cycle. So we're going to use it with this methodology called the fast and slow pointers. And the fast and slow pointers are really straightforward. It just goes something like this. You have a linked list. I'm sorry, you have anything. You have anything. In this case, it's a linked list. But you've got 2 pointers. They're just pointing at different points in some iterable, like a list or a string, right? They're iterable because there are pieces to them, right? So you have that, and one is pointing one place, and one is pointing the other. They start at the same area, and one moves to the iterable one way, and one moves to the iterable in another way. So one's going slower than the other, and one's going faster than the other. Why is this important? Because we're trying to understand if we're trying to achieve something. So a good explanation is probably put down here. Unlike the 2 pointers approach, which I've talked about before, these are 2 pointers, but it's fast and slow 2 pointers, which is concerned with data values. The fast and slow pointers approach is used to determine data structure traits using indices in arrays or node pointers in linked arrays. The approach is commonly used to detect cycles in a given data structure, so it's also known as Floyd cycle detection algorithm. The key idea is that the pointers start at the same location, but they move at different speeds. If there is a cycle, we'll talk about what a cycle is in a second, the 2 are bound to meet up at some point in the traversal. To understand the concept, think of 2 runners on a track. While they start at the same point, they have different running speeds. If the racetrack is a circle, the faster runner will overtake the slower one after completing a lap. On the other hand, if the track is straight, the faster runner will end the race before the slower one, hence never meeting on the track again. Okay, so let's do that. And let's talk about real world problems. Well, they talk about real world problems. I'm not going to talk about those real world problems because I don't think they're going to be very useful for us. But what we can do is just look at this to understand what a cycle is. So a cycle is this. You go to the end of a linked list, right? Can you be done with the linked list, or does it point you to another node somewhere within the list? And does it always happen that way? If you traverse just naturally, bam, 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 stop, or do you bam, 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 back around, bam, 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 and it's never ending? Does it go like this? Is it a cycle? That's basically what we're trying to do. Well, how are we going to determine that? We can determine it as follows. It might not seem intuitive, but it is. Both of these pointers, one faster than the other, start at the same place. One moves forward one moves forward 2. So the first one is here, the second one is here. Now we move again. The first one is here, the second one is here. Okay, now we move forward again. The first one is here, the second one is here. It's at 4. Now the first one is here, the other one is here. Okay, now first goes down here, and the other one is here. Now the first goes here, and the other one is here, and they're both on 6. Oh, they're both on 6. That shouldn't be possible. That's how we know it's a cycle. It should not be possible for the 2 to overlap unless there is a cycle. So we know a true or false statement. If they ever meet, we'll know. It might not be the most efficient way. Like, wouldn't it be nice to just somehow in some other way determine that there is a cycle? Yes, but this is a common way to do it, and so we're gonna do it like that. Okay, so that's the idea. And here's the step-by-step instructions of how we're going to initialize both of the fast and slow pointers to the head of the linked list. Move the slow pointer one node ahead, the fast pointer two nodes ahead. Check if both pointers point to the same node at any point. If yes, then return true. If the fast pointer reaches at the end of the linked list, return false. So if it hits an end, we'll know. Ideally, that's the part we'll hit fastest, right? So if we just hit the end, well, then you know your answer. Okay, so they give us some code. We're gonna start from the very beginning of this code. It is actually very useful. We might even like end talking about this code and then solve the problem tomorrow or something. But man, I really wish it weren't. See, like if I do that or something, if the focus is worse, then I look less absolutely pale. Hold on. I just don't want people to. Is that better or worse? One sec. That might be better. That might be better. Can I do this? Will that change anything? Okay. Just so. It makes it a little worse. We're working on it. We're working on it. Sorry, y'all. I'm just learning my lighting. I might have to figure out a way. Because I have like a window right here. Because I like to see the outside world. Okay, so let's actually go through this, and maybe we'll finish today with the actual problem, but at the very least, what we're gonna do is go through the code and try to understand it. There is no rush here, right? This is why one of the reasons why I'm doing this. I'm doing this out of pleasure. It may seem like that's a crazy thing, but it is true. I am doing this out of pleasure. I do enjoy this. I'm sorry. The thing about it is, make a new file. Wait, what do they call this file? They call it linked list node. We're going to call it that too, just so we have what we want. Linked list node. Working through other people's code that you did not write yourself is really important to learn how to code, right? It also, like, you're not going to understand when you're starting off everything that's going on. It's like reading a classical book. Like, you're gonna read through it and people are gonna know things about it because they have more experience in the field. And they're like, actually, they're referencing this. And you're like, oh, I didn't even know that. I looked at this and these were just words. And it's like, yes, because you're not an expert. That doesn't mean you shouldn't read classical books, and it doesn't mean you shouldn't be working through other people's codes. And so we're gonna do that, and that's gonna help us learn Java. And also, it's gonna help me learn Java because I've never learned Java. I am learning with you. All right, and anything we don't know, guess what? We get to look up. The best part is we can take it as slow as we want. We don't have to understand all of this, and we don't have to understand all of it today. But before we do that, I need to take a quick, I need to open an app because it is making tons of noise for me. And I'm gonna go to my preferences or something and try to turn off the sound because preferences, notifications, I'm sure. There's gotta be notifications. Mark as read, accessibility, messages and media. Because I think you could hear that and notifications is right there. No. And choose how notifications look, sound, and behave. Mute all. None. And actually do this never. Like, I want to mute all of it. Just so you're not seeing stuff. Notify me about nothing. Okay, that feels right. Great. Sorry. So, there's no rush. The joy of life is learning things. I know it might not seem that way to you. Sorry, I can't tell you what your joy of life is. A joy of life is learning things, and I think most people could agree for that. We are trying to better ourselves. We're trying to learn how to learn. We're trying to be engaged people about the world around us. Java is used many different places. And I said, even if you're not doing Java, if you do C#, it's functionally the same thing, right? You're learning a lot of different things. So, all right, let's work through this code and see what we see here. Okay, so they built a node differently than we built a node. Wait, is this linked list node? This linked node? Linked list node. Yep. They built a node differently than we built a node. That's the first thing I notice. That's kind of cool. Okay, so now we get to see a different way to make a thing. Great. What's the problem there? Absolutely nothing. You can do in coding the same thing many different ways. People would like it not to be the case. They would like it to be one way. That's not the case. So how do they do it? They have this class, and then in the class is initialized two public objects. The idea here being public as an accessible, it doesn't just stay within the class. So someone else, some other class could use this object. Not an expert, just know a little bit about, this stuff. Sometimes I'm going to be researching things and I'm just not going to know. And you're going to say, Ben, you're an idiot. That's okay. I'm about to get to algorithms where I don't have the answer. Okay. We'll work together to solve it. Int is data. Int is data, cool. And then there's this linked list is next. Okay, interesting. How does that, one question that, arises to me is, how does that differ than what we did? I don't remember. Okay, so we did do the same thing here. We called node next is next. So it's functionally the same. It's just they wrote it in different orders. Another thing that's kind of interesting here is that they don't assign next to equal null right away. They just initialize the object. Okay. All right. So now what we have here is this linked list node. And the linked list node takes a data object, and the data object is going to be assigned to data. We called it D, they called it data. You could call it foo, you could call it blah. It doesn't matter. It's an int object that's being assigned to this.data. This, again, is self. So it's saying linked list has this object data, and that's going to be an int, and they're passing another object when you construct it called data, and it's going to call data, and this.next is going to be none or null. Okay, so that's the first code that we inherited from these people. Let's grab the next bit of code. Before I show you that code, I want you to know not to be overwhelmed by that code. How can I force you not to be overwhelmed? By yelling at you. No, I'm kidding. Don't be overwhelmed, right? We're going to break it down. The whole point of code is breaking things down, just like most problems in the world are things that you can just break down. So we're going to break it down. And if we don't understand it, we'll work to understand it. And if we end up never understanding it, that's okay too. But I think that's not likely. All right. They called it linked list Java. So let's look at the code. See, it's a bunch of stuff all at once. We'll figure out what we can do about that. It looks like this part of their code is never used, so we're not going to use it. We're just going to get rid of it. We don't care. We're doing what we want. Okay, so they're doing a bit of documentation here. That's kind of helpful for us. Let's look through the code and see what we can see. All right. First thing I see is that there's this class, and then there's this T object. I apologize. I had seen this before a bunch of times, and I just never got around to looking at what the frick it was, right? What is this T? What are these diamonds operators right here, right? Okay. I looked it up ahead of time because I was curious this morning when I was kind of glancing at what I was thinking about doing later in the day. The T stands for time to get out. No, it stands for generic type. What? So basically, this is an interesting thing to me. Throughout our Java code, we're putting these types in front of all of our objects to tell the compiler, the just-in-time compiler, the JVM, that's what Java runs on. Doesn't matter what it is. You can know that it exists. You don't have to know all the details. You can hand wave things. There's a JVM. There's a just-in-time compiler. Those are things. And we give all of these objects types. It says, this is going to be an integer. This is going to be a node class. This is going to be a blah. This is going to be a blah. Sometimes you want to use your own type or a type that doesn't exist. That's okay. And so that's what T is. T is saying this is a generic type. This is just a type. And the way that we assign that type to an object is through the diamonds. So these are our little diamonds. These are little crocodiles, okay? That's basically all you need to know right now. As far as I understand. I could be wrong. All right, so we got linked list T, and we're creating this class right here and good stuff. That's fun. Next, what is going on? Well, okay, it's anticipating the need for something called head. They called it head. We don't know what head is. We can assume what head is, but for right now we just say there is a thing called head. Okay? Well, they're assigning the type. I said it weird. Assigning? They're assigning the type to head, which is something called linked list node. But that's kind of interesting, because linked list node is this code right here that we made. Oh, so we're using something we created somewhere else. We're actually building a program. That's kind of neat. So we're already getting to the point where you had a thing and we can actually use it. Well, great. So we now know what head is. Head is a linked list node. We don't know what to do with it yet, but we know that we can use it because it's public instead of private, which means like it's not going to leave. So it's a linked list head, which means that it has the object, it has the capacity to do these things. To look at some object called data, which is an int, and to look at some object, which is a linked list node called next. All right, so we already know features of head. Good stuff. Now we have our constructor. Our constructor is the thing that's called the class name that does a thing, that creates the class, right? So in this case, it's an accessible object called linked list, which makes sense because we have to call something linked list. That is the object. And it's saying, they gave us a note, and it said constructor will be used to make a linked list type object. Good enough. What is this thing? Well, we can already see where I can already see where I think they're going on this. Again, I'm not an expert. I am just working line by line through this code. And it says that linked list has this dot head equals null. All right, and notice here that after every line of code, we will put a little semicolon. That tells the compiler that done with this. Cool. So linked list has this, so it's saying like the object itself dot head equals null. Okay, so it created a head object, but really what we could have done, just like I did in here, is you could have basically said this. They're basically saying the same thing. It's functionally the same. What we've got here is we're saying, okay, head here equals null, but it won't always, I'm assuming. That's just what I got. Okay, so we create a constructor. There's going to be a head object, but at first it's not going to have anything. Great. Next, insert node at head method will insert a linked list at head of linked list. Okay, well, sure. How's that going to work? I had to stare at this for a little bit. That's okay. We stare at things. So it's an object, an accessible method with the type linked list node. So you have to pass in a node called blah, in this case node. And the action we're doing is this when we call this method. If some condition occurs, then do a thing. Otherwise, do a different thing. All right, what's the condition? The condition is if this dot head, which we already created, equals null, then assign head to node. In other words, if linked list is empty, then all you need to do is just say the first object that we're passing in is going to be the head object. Okay, great. So we can write that out. There is no harm in writing out some piece of information that we want. Feel free to type up your code with comments when it's just your code. You're not doing it for anyone else, you're doing it for yourself, right? You can do this stuff for other people, but You might want to refine your comments if you're sharing code, right? But mark up your code as much and as often as you think is necessary. And in fact, I encourage it. All right. So we have this. So that means if object initially is empty, the first node passed should be head. Should be head node. I don't see a problem with that. Next. Otherwise, if it's not empty, so we can really just infer that because there's only two options. If there is a node in the linked list and a node in the, and head and its head dot, its dot head is not null, then what? Then go, let's see here, go to this dot head, which we know this dot head is a linked list node, so it's a node, right? Okay. Grab this dot head. At first it's null, but in this case it's not. It is a non-null, and assign node dot next to that head. What is node dot next? Well, where does node come from? Node comes from here. All right, let's break this down. I'm literally breaking this down with you as we speak because I forgot, like, whoa, there we go. It went black. My screen went black. What node dot next is. Okay, what is node dot next? Well, it's this object here. Let's just break it down. Where does this go? Oh yeah, it's this thing. Dot next. Oh, that's this object, but what does that do? Ah, it's null. Okay. So this node object does have a dot next attribute. So every linked list node object has a dot next attribute. Assign head to it. Okay. And then you're saying what? This dot head equals node. Well, node is this thing right here. So now you're saying, now that dot next is, head, whatever, which was either null or a linked list node object. And we can make this longer. I'll just take this here. Doesn't matter. It's our code. We can do what we want. Heavily mark it up. Now that is the case, then assign self head as node. Okay, so that's fine. So we've done something with what head already was. It's this. But there is a problem here. And the problem that as I understand it is, well, where are all the objects going? Aren't we going to write something? We're going to look at that in a bit, right? And see what happens. Okay, but for now, we kind of get an understanding of what insert node at head is doing. Let's just keep going. All right, it's got two more methods for us, a get length and a get node. Let's just walk through. Oh, and a create linked list, obviously. All right, so create linked list. Method will create the linked list using the given integer array with the help of insert at head method. Okay. How is that happening? Well, we'll create a linked list with a list of integers. That's what this is right here. A list of integers called list. It could have been called anything. We're just going to call it list as an argument. It's just a name that holds the space for the object. And we're going to do a thing. And the thing we're going to do is this. We're going to iterate through the list. How? First, we're going to create an object of int type. It's going to call it I and assign it the length of the list. Well, since this is a list of integers, we know for a fact that the list type of integers has an attribute called .length. So that works. So we're calling the length of the list, but we start counting in Java, as in Python, at 0, which means we have to subtract by 1 to make this work if we're starting at 0. And since we are, here's how it's going to work. For every integer from 0, where we're starting at the end of the list, for every integer starting at the end of the list, as long as that integer is greater than or equal to 0, subtract I and do a thing. Okay? So the first thing we're going to do is we're going to create a new linked list node. We're going to say the ith integer, this first we're starting at the last one, and we're going to do a breakpoint here to see what this looks like. And then we're going to see this, and then we're going to see this, this, and this, and this, because I want to see it all. Okay. We're going to create a new linked list node object, because right now it's just a list of integers, right? Which is static. It is not a dynamic list, right? So this, we told it, your list is going to be for long or something, right? That is what you have. Okay. So we go through and we say, for every integer starting with the ith integer, which means at the end of the list, grab the integer and plug it into linked list node, which means we're going to create linked list node. Back here, we're giving it an integer, which means data is going to be data. So there's going to be a this.data and a this.next, and that's what we call a node. We're going to create a node. We're going to call it new node. It's going to be of linked list node type. And then we're going to do something with that node. We're going to insert that node into the list. If the object is initially empty, then we're going to do a thing. Otherwise, we're going to iterate through, get the head, call it next, and then assign head as the node. All right. So we saw that was going to happen. We'll go back to that in a second. We don't actually do get node or get length. So we can just start here. So what I'm going to do is we're going to public static void main string list args thing. I'm trying to remember how to do that. Oop. Do a thing. What we're going to do, is this right? I believe it's right. I'm so used to Macs. There. Go to the node Java. Didn't I do it here? Public static void main. Yes, public static void main string args. Huzzah! All right. So we're going to go through. Where were we? I was right. And we are going to now, let's run this. So we're going to create a linked list. How are we going to do it? We're going to go bam, bam. Oops. We're going to create the object first. So first, we have to create the node object. So we go, this is linked list. I'm sorry, not the node object, the list object. Linked list, we're going to call that object. Now, the first one is going to be some type. Let's call it something. We're going to call it our list. Our linked list. It doesn't matter. It goes this. And now we're going to create a new version of it. New linked list. We're going to construct it. But we have to pass it something, don't we? We have to pass it an int array of type. I think it says this. Let's call it 1, 2, 3, 4, 5. I think that will work. What do I have wrong? Let me look at my old code. We're learning together. I made a list before. Where is it? Java list. Oh. It is... I was close. I got to do this. This is how you make a new. So it's new int list this thing. I think that's what it is. Now what? That's right. Is undefined. You're saying it's undefined. I'm saying go to hell. Let's see who wins. Maybe it's this. That's better. But now is undefined for int. Doesn't it take linked list. Mm-hmm. There's a raw type. References generic type should be parameterized. T. Like that. I'm doing something wrong. All right, I'm going to ask for a hint. That is perfectly okay. I'm getting a hint here. We'll see what the hint is. The hint is... Oh, okay, let's try it. So the answer here is, this is what I had, and it might be better to be as this, and then pull in arrays. That could be an answer here, but I don't love it. So we're going to try to amend the advice I got. Get rid of this. So this part is technically true. So the generic says it can be of any type, but we still have to give it a type. And right now we're giving it of the type integer, but then this is going to be, cannot infer the type for the linked list. Let's do int. Maybe this will do it. It's okay to be wrong. It's okay to not know. Do it anyway, and then we'll have a fun time. All right, let's see. How about this? Syntax errors into a misplaced construct. What if we did this? Let's call arg1 equals this. Okay, so that part's right. Now we have a list. Now we're passing it in, arg1. And linked list is going to be... Do I do dot get linked list? Dot linked list? Let's see here. Oh, that's interesting. I didn't know this. Okay, so something I learned. This is why we're learning Java together. First, with the generic type here up here, you cannot give a primitive type to a generic type. It has to be a non-primitive type, which means this has to be integer, like this. I didn't know that, so I learned something new. The next thing, well, so like that's a huge thing. So if this is the case, integer, then I would have to turn this into an integer object as well, which means this would have to be an integer list. So this would be integer dot, shit, I haven't worked with that too much. Is it, what do we got here? I see. So I could do something like this. Our linked list, just call it raw. This should be of type integer. New linked list needs the unchecked version to confirm. She parameterized like this. Yes. Okay. So you put the diamonds in there so that you can say it's a generic type. You create this integer type here. I think this is still wrong because, oh, let me get rid of this. Last thing I'm thinking of here is, and I said, like, we probably won't get solving the problem today because there's a bunch of stuff we're going to want to go through in this code. we've got this list of integers. We've got this integer type, but it's not a primitive type. Create linked list expects integer list of lower type integer right here, right? That's fine. Wait a second. Could I just do this? I wonder what, maybe this will work. Okay, let's try with running our debugger. So we're gonna run this with our debugger, see what we get. We're learning together. So debugger runs, and first thing it does is it runs this right here, and we're okay. We got through the first one. We created our linked list, and head is null, which is how this starts, because we create this linked list here. One thing I learned right here, so I'm gonna comment this in right away, is with a constructor of empty that has, wait, linked list. Yeah, it doesn't have any arguments. It has no arguments. You can just call. Cool. Next thing I learned, be sure to assign non-primitive, primitive. How do you spell it? P-R-I-M. Yeah, it's with an I. Okay, primitive. Be sure to assign non-primitive to a generic T-type. Okay, so we're going to call it an integer. Great stuff, great stuff. Then what? We created our list of args. This is fine. Keep going. And something happened. Oh, we're paused. That's good. So we created that linked list. We got to the point where, hold on, I want to stop. Why did this not break the way I wanted it to? I don't know for sure. Let's run it again. That worked. That worked. Okay, there we go. Now we're paused at where we wanted to be. So now we have our linked list and we have our args, right, of our arg1, and we have all of these values. And again, it starts counting at 0. So 0, 1, 2, 3, 4. Cool. Next, we go where? We go to this. So we go here, and we're going to start. And we're going to start at this. So let's go. We started at this list. This, remember, this is this object. So this will be the the linked list object here. And we're saying I blah, 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 blah. So let's go to the first. What is it going to be? Well, it's going to start at 4 because 1 minus the length of the list, right? 1, 2, 3, 4, 5. So it's going to be 4 because we start counting at 0. So it is a length of 0 to 4, which is 5 long. Right. Now what we're going to do is we're going to go to linked list node. I wonder, I actually don't know the answer to this. Can we breakpoint this as well? Let's find out. We're going to go here. We're going to create a linked list node. There we go. What happens? Yes, we can. Hell yeah. I love my debugger. So what happened? We went here and we created a linked list node out of the ith object. In this case, we start with 4, with the number 5. So we start here. Now it's a node object. It is a node object created by this node object here. We passed in 5. Now 5 is being assigned here to this.data, which means it's going to be called a linked list node object. And next is going to be 0, or null, that is. Next, now we're going to insert node at head. What happens here? So we go to insert node at head. What happens? We go up here. It's going to say, what is this dot head? Is it null? It is null. So this dot head should equal node. And it does. So now head is going to be this, and it's going to be data5 next is null, which is exactly what this object is. Great. Let's do it again. This time we go through this dot. We're going to be this dot data. We're going to create this linked list. Perfect. It's going to be exactly what we thought it was. All right, but what's going on here? So now we have new node equals data.next, and we have head or this with head.data.next. This is what I want to understand. What happens when one already exists? So we do it now. We have 5 and 4. What's going to happen? We're going to say insert node.head. Insert node.head. This does not exist anymore. Next is not null. So we say what's happening with node, this dot head. We move forward. We're going to be node.next, this dot head. Oh, this is very useful. I'm glad we went through this. Okay, but what are we passing into insert node at head? Whoa, 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 whoa. I misspelled this. We have to start all over. I want to make sure that I don't run this wrong. So hold on. I'm just going to get back to 5 and 4. So go through. 4. Okay. There we go. There we go. There we go. Okay. So we're at the third, which means data is 5 in there. We go through, we've created our data type. All right, there we go. So we've got this new node, and we're going to say insert node at head. Insert node at head grabs this node right here. It goes through, and then it's going to say, well, if this dot head equals null, this dot head does not equal null, it equals this, do a thing. So instead, it's going to go down here. Now it's going to say node.next. Node.next is null. So this is going to be head. There we go. So then we go here, create another one, Let's go back to the one, our current state of things. Our current state of things is we have head is 4, data is 5. Move through, we're on our new object, so we should be at object value 3, which is now a node. Go through, is this dot head null? No. So then we go to node.next. Node.next. Node.next, that is the node.next of the object we're passing in, is now this dot head. Node.next, this dot head. So node.next will always be null because that is the object. We're passing in a new object, and we're assigning it this head object, and we're saying this dot head is yes. This dot head being this dot head, which is this. Oh, that's so cool. Okay, I see it now. I love talking this shit through. Okay, I'm gonna reword this because it makes a lot more sense to me. If the passed in node, this is what matters. The passed in node, let's say that, will always have this or node.next equals null since it's new. So take the existing, I'm going to put this as a bigger note here because this is so important and a realization for me. So take the existing, we'll make it a long note. We can do what we want. This is our notes. This is our code. We can do what we want. Existing node object, and actually make it subsequent. I'm going to call subsequent. Subsequent to the past in node. Now, past in node Now passed in node, we don't need all caps, is head, and the previous nodes are follow it. We'll call it that. Okay, I conceptually got it, but it didn't ring for me. So this is great. So that's what's going to happen here. Now 3 dot next or null is actually going to just take all of this, and it is going to be the new this, because this dot head is now node. So we'll do that. Now look at this. We go up to 3, and it has the same values as this one. This one has the same values. This one has the same values. 3, 4, 5, 4, 5. It has 4, 5 in it. Oh, so this is so elegant. We do it again. So the next one, 2 is now going to have all of this. So we have 3, 4, and 5, which is what we just did. New node has 2. We go through. New node is going to have 2. Ready? New node is now going to have all the object values that we just created. 3, 4, 5. This is now 3, 4, 5. And 2, 3, 4, 5. And one more time. And we're done. It's going to be 0. It's going to be the last value. We know we're done. And that is how you put a header there. That is so elegant. I didn't think of it like that. But you can take this object and now make it you can make it the head object. And seeing it through the debugger is huge. Being able to see through the debugger is exactly what we need to sort of understand what's going on here. So very happy about that. How long have I been streaming? I don't even know. Let's just keep going a little bit longer. So that was very useful to me. That was very useful knowledge, and I love learning this stuff. There we go. Focus back. Okay, so we have one more. We have 2 more methods, but I'm not going to tackle them unless we need them. I think we are going to need them, but let's just see. So I'm going to go back to the code, and there's a third piece of code here, and it's going to be called detect cycle. Okay, so we're going to call it cycle detection.java. Cycle detection.java. And this is where we're going to try to navigate the linked list and determine if it's a cycle or not. So let's get an example. So let's go back to the code here, the examples they gave us. All right. So the first input of the test case includes an array representing the contents of the linked list. The second input represents the index of the node to which the tail is pointing. It will be -1 in a case of pointing to null. The second is not passed as a parameter in the function because it's just represent this cycle linked list. Okay. All right. So the input of the test case, I see. Input 1, input 2. The first input of the test case into an array representing the contents of the linked list. The second input represents the index of the node to which the tailor is pointing. It is not currently pointing to any. It will be -1 in case it's pointing to null. Second input is not passed as a parameter of the function because it is just representing linked list in cycle. So this is pointing to the first. This is pointing to that first, that first. Okay. Now, let's see if any of these are cycles. How will we know? There's got to be a way, like, am I not seeing something? How do I know if one is... Let's give some examples here. Get some examples. What is the output of the following? Will this be a cycle? Yes, because we can see the arrow, basically. We can just, if you see an arrow, it's a cycle. Cycle. No cycle, false. Okay, but looking down here, how do we know they're a cycle? I honestly don't know. Let's find out. 2, 4, 6, 8, 10. 1, 3, 5, 7, 9, 1, 2, 3, 4, 5, 0, 2, 3, 5, 6. See, I feel like 3, 6, 9, 10, 11. I feel like there's significance to the numbers themselves here. Checked whether or not if a cycle is returned to the next pointer. The cycle means that at least one node can be reached again by traversing the next pointer. But how would I? These are all. I would have. That's a good question. How do you know? I know the cycle part of like the arrows, but what is it actually functionally? Let's find out. Let's try to solve this. I don't see it right away. There must be something I'm not seeing, obviously. So let me go back and think slowly. Cycle detection. Link detect cycle Boolean head. Replace this place with linked list node get node returns the node to specified position. Returns the number of nodes in the linked list. I'm gonna look here. ChatGPT is gonna tell me what's gonna go on here. Hold on. All right, let's see. What are examples of arrays that are cycles and those that are not as lists of integers? Explain briefly. Let's see here. Situations where traversing the array of some rule leads you back to the starting point, forming a loop. Or arrays to exhibit cycles, we need a rule to move from moving one index to another. One common rule is to treat each value in the array as a step size. These are step sizes, not. Oh, are they saying these are step sizes? Oh. Let's try. What? Like, let's try this. What would it say it is? It would say that this expected true. It would say that this is a cycle. This is a cycle, and this is a cycle. This is not a cycle, and this is not a cycle. Got it. All right, so far so good. So why is this a cycle? This is a cycle because 2, 4, 6, 8, 10. If one starts here, one starts. I don't understand. Let me ask this. I don't think we're given a rule here. So this is sort of bad. This is not actually a good example because it's not telling us how we know whether something is a cycle, just that there exist cycles. We are going to have to skip it. But that was really cool. All right. We're going to skip this problem because it's not well designed. And that is not on me. I mean, we can look at the answers here. The distance of pauses is a list head print with forward arrow. main.py, main.java, site.slow head, where fast does not equal slow.next if slow equals fast. Okay. So they're just saying if head equals null, then return false. Linked list slow, link is head, linked list fast is head, while fast does not equal null and fast.next does not equal null. Slow equals slow.next, fast equals fast.next.next. If slow equals fast, true, otherwise false. Okay. And then we have these examples. All right, this is actually really straightforward. So I'm just gonna, I didn't think this was very well explained, but I will explain the code here because it makes sense. So let's just do it. So we go to code here, blah, and then let's just go through the answer quickly. So cycle detection, we're gonna take it, we're gonna do this, and then we're gonna get this, and then we'll add a main. And we'll be happy with ourselves. It's fine. Okay, so let's give an example. Let's use some of the examples that they had. I don't really care. I think it was a poorly described problem, but I'm not mad. I'm just disappointed. Let's take their example here, and we can pass in list.node. Okay, that's fine. One sec. What do they do to the inputs here? They say blah, blah, blah. Hold on. Detect cycle. Where do they do detect cycle? I'm just looking for that. Detect cycle. Ah. That's fine. Here's how we'll do it. So there's some input length. So we'll say let's call this our input. Call it this. We'll go to our linked list node Java, blah, blah, blah. We'll grab this one. Cycle detection. We'll call it this. There we go. This is our arg1. We'll call it list. And let's grab their actual example, which I was saying I was doing, and then I was trying to figure out how they were running this thing. So they have this 2, 4, 6, 8, 10. So we're going to do that. 2, 4, 6, 8, 10. Get rid of this. Get rid of this. Then we're going to say for this, because it's an integer list, we can grab it. We're going to go through the list, and we're going to create list called, we'll call it input, aren't we? We're going to call it input. Linked list. Yeah, we're going to call this input, or arg1. It doesn't really matter. We'll call this arg1. Then what we're going to do is arg1 there, and then list.create list linked integer. This method is not applicable for the type int. List arg1. There we go. Arg1 and input I. This is a linked list. Position linked list out. Create linked list. I list.head. Create linked list. What's wrong here? Oh, do I need to like import it? No, because we know what linked list is. Is type integer. This should be type. Create linked list of type int. Let's do type this. I'm gonna figure it out. No worries. I'm getting a hint here, see what's going on. Well, their use of generics seems completely just incorrect. But here, I see here. I don't need a for loop here, first of all. I can just do, let's try this. Let's grab this and go back here. All right, so far, so good. So we called it an integer, our linked list, and this is linked list, and we're good to go. But then what we want to do is we want to call this that. There we go. Okay, we're good to go there. And then finally, we're going to say get back detect cycle and print out this. Okay, let's try running this, but let's also talk through the code, what's happening. And specifically, this thing here that I just sort of like hand waved, that wasn't really good explanation on my part. I understood it, but I was just like, okay, fine. I don't like how they wrote out the problem, so that's kind of where I was like, whatever. All right. So first things first, we create a new linked list object. The linked list object comes from this linked list code here, right? So we knew what that was. Now we're going to create our list. Good stuff. Then what we're going to do is we're going to create a linked list out of this argument. We'll create linked list. We go to create linked list. We're going to do this. We're going to go through each of them and just insert nodes at head. So we're going to go through, do this. This is what we did before. We're just going to create a linked list out of this for each, and it's going to be a node. I love this so much. So we're going to do it. We can remove these because we know what happens here. So we won't have to go through all of them every time now. Let's just assume that we know this at this point. Now we say detect cycle. What's going on here? Okay, first, if head equals null, then we can just say it's not a cycle because there's no list. All right, fair enough. Let's say that we're going to call this object slow the head of the linked list that we got, which is we got the first item from the linked list. Then what we're going to do is we're going to iterate, because this is a linked list, we get all the other objects. We're going to say while fast does not equal null, that is, while fast is not empty, and fast.next is not empty, go through, first grab the slow object. Let's just do this one at a time. So we've got these objects here. Now we're going to say, what is slow? Slow is data 1 and 2 and 3 and 4. Okay, 1, 2, 3, 4, 5. So we go through. We're going to say, well, dot next. So slow dot next is 3, and slow and fast is next dot next, right? Because we're going 2 versus 1. So we go through, and we say, is slow equal to fast? Well, slow equals this 3, 4, 5, and fast. Sorry, slow equals that. Slow equals 2, 3, 4, and fast equals this. So do they equal each other? No. Keep going. How about now? Keep doing it. Keep checking. And once they equal each other, then return, does it have a cycle? And the answer is false. But now these are the examples they gave us. Let's give one which we know should be true and see if it works. This should be true. So we take these numbers, 2, 4, 6, 8. 2, 4, 6, 8, 10. This should return a cycle according to our overlords. So we run it. At some point, the rest should be the same. So we run it through, and we go through, and we go through, and now we're going to get the answer, and it's going to say false. But when we run it in here, they expect true. So something is wrong with our, well, actually it's their code because I literally just took it from them. It's just a really poorly worded question. Detect cycle list.head. List.head. List is created input I. Oh, this should be a for loop because this should be a for loop. Oh wait, no, I is. No, it shouldn't. It shouldn't be a for loop because you just can pass the entire list in there and it's just going to go through and create it. So I'm honestly going to say that we get the idea of this, but that the implementation is poor on their part, and say that we basically did enough here to call it. We went through all this code. We understood what cycles were. We understood an algorithm to how to get past it. I can iterate more on this later, but it matters a little bit less. And I will say that that's it for now. I'll be back in a few hours to game. But all right, thanks y'all. This was fun.